This is a production of Cornell University.
So it's Masters Week, right? It seems like the world stops for us in the golf world when this happens. We talked about it last week, talk about it again. And in honor of that, we got a sports turf discussion today. So we are going to find a way to twist this thing into a golf discussion to the start, Evan, and I'm going to ask you a couple of questions, and I'm wondering your thoughts, because there are some things I think for golf folks that are listening that I think will be really fascinating, because we're starting to look at putting surfaces in a way that you used to look at baseball infields, if you don't mind.
Sure. Hey, golfers are athletes too.
Yeah, that's right. They are now. That's for sure. We got this note. Carl and I got this note from our good pal Rick Slattery, who's down at the Masters. What did he say, Carl? He walked 25 miles in 2 days.
Man, he's putting the steps in.
He is putting the steps in, and thrilled to see a pimento cheese sandwich for $1.50. And anybody that gets down there knows that's exactly how this works. Carl, come on with this guy. Taped his mouth shut because he couldn't hold his tongue. He was getting himself so upset. I'd like to hear your thoughts on, taping your mouth shut. I think this should be something we could use in other parts of our lives as well. Why should it be confined to this guy? What are your thoughts about the mentality that drives a golfer to do this ridiculousness?
This speaks to my theory that golf just makes people crazy. And, you can see really smart people just in all other walks of life. And as soon as you put a golf club in their hand, it is all out the window for whatever reason.
Well, this poor guy, I think, played a Corn Ferry event like this, and was completely serious about it helping his game. A couple of guys that don't need help, and of course, as an old guy myself now, just want to raise everybody's attention that while Ludwig Olborg at 20 years old or 21 years old is on the leaderboard, my man Freddie Couples is T13, and Bernard Langer, 67 years old, will probably be the oldest guy to make the cut. He's at even par right now, so we'll see how it goes today and what he's able to do. But we're very excited about these two old guys really showing up. Okay, Evan, so we talk about firmness on putting surfaces, right? I know we're going to talk about your line of work and that you're currently doing with Biocore and in field safety and measurements. We look at a variety of different ways. There's a Clegg hammer on the right making an indent, and either a traditional true firm or even the PGA railroad ball bearing that they drop at a uniform height to measure firmness. So this is a very commonly discussed term now. It's getting more widely known. What is not as widely studied and known is the strength of that surface, right? And you studied this a little bit with your clay work years ago. So, no matter and of course, this may be the first Masters they have that's really firm and fast, because they get rain all the time and then they run those sub airs and everybody's the sub air thing. And this still happens in the top millimeter, no matter how much they run that sub air. So here you are, Ev, back in your Pittsburgh Pirate days as a working man. Now you're a senior engineer with Biocore. And when we had you on years ago, when you were doing your infield work, we were talking about cleat in, cleat out, and how the ball was responding to these clay surfaces. So my question to start this out before I get to the weather and we get to the meat of the sports conversation today is, what are your thoughts about ways of potentially measuring this or understanding it a little bit better on a putting surface?
Well, I feel only a little ambushed by this question.
All right.
So I think real quick, just from an engineering standpoint, there's all different kinds of gobbledygook terms that people use to describe materials. Young's modulus, elastic modulus, shear modulus, and all these terms describe the way that a material deforms in different directions under different means of loads, right? So firmness is typically thought about in the vertical direction or normal forces.
Mm-hmm.
Whereas a shearing strength, I think that's pretty intuitive. I think most people understand shear strength to be in sort of a perpendicular or coplanar direction to the surface, right? So in sand root zones, we're really relying mostly on the anchoring of the grass plants to provide the stability. My old advisor Andy McNett, he would say, you know, we've tried in the past to stabilize sand root zones by changing the particle size distribution, and with this sort of the CU concept that's really caught on in the golf course world for firmness. Well, if you do this sort of thought experiment when you have an athlete running around on the surface with no grass, if you had this high CU sand that's very non-uniform, and ideally you could have some of the particle packing working to fill it in, do you really think that's going to stabilize the surface? Or I mean, the reality is those athletes are going to still blow that sand all over the place, right? So you're really relying on the network of roots and rhizomes in the case of a Kentucky bluegrass sports field or a Bermuda grass field. On a golf course, if it's a bent grass or even a bent POA surface, you're relying more on the stoloniferous growth habit, which is contributing to this organic matter on the top. So that, I guess, that's kind of a starting point for the conversation. We're really, I think in this case, concerned a little bit more with the organic materials, whether they're living or dead, and then certainly the degree of decomposition on the top.
See, this is so great. I ambush you and you give me an answer like that. I got to do this more often to people. That was absolutely brilliant. And I think you're right. What we're there's two parts to this. One is, how do we measure it, right? To simulate a ball. There's a lot of discrepancies, even in dropping a thing down on the surface to determine it. Is it correlated to moisture? Is it correlated to organic matter? Now, we have the USGA method of organic matter testing, the OM246, where
right, the 246.
you're honing in on the 2 millimeters. So I think there's no answer. This is what's great about this. This is the beginning of the thinking of how we have to measure this, because firmness is only part of the equation, right? You can get it firm, but when you get those forces from other directions, especially when you consider the spin rate. If they're hitting a close iron that they can use the grooves and get the spin on the ball, it really adds quite a bit of complexity. And then at the end of the day, what does a golf course superintendent do? Should we verticut and put more sand in here? Did we need to aerify? Is it a brush? Does brushing help? I don't think we understand really what it takes to manage that upper millimeter, right, Evan, where this reaction is occurring, right? It's not a deep thing. When the ball hits it, we're only talking about a millimeter or two, right? Different than your sports field where the cleat is entering into the substrate a little bit. Yes?
Yeah, I totally agree. The surface really is what you're managing. So, honestly, it's similar to an infield skin. You're really managing that top, maybe inch or usually less than that, just where the cleats are interacting. And in this case, where the ball is interacting, I think one thing that sticks out to me on this picture, you can see, obviously the living plant material on top, but this sort of turf slime or relatively, degraded organic or intermediate degraded organic matter anyway, which has very little shear strength and probably whose physical properties is highly dependent on the water content. That type of material has a very high water holding capacity due to its sort of, I guess, molecular structure and, its sort of randomly oriented organic molecules, but also will depend highly on the water content, right? So when it's dry, it's pretty stiff. It's probably compressed a little bit. When it starts to absorb water, it's going to swell. And even if there is some sand in that top layer, some grit, that swelling can potentially open up that that medium so that the sand grains are no longer in such intimate contact.
This is so great. All right. Okay, let's get to the weather, and then we're going to get to the meat of the discussion. It's been pretty wet. We're going to talk about temperature in a minute, but when you look at sort of rainfall across the region, there are very few places, maybe along the Great Lakes, where we were a little bit drier. And it looks like the coast is going to stay wetter than inland. So if you're along the coast, you can expect quite a bit of rainfall in the next few days. It could be a washout of a weekend. I hope I'm not in the baseball business, because I'll be dragging a tarp a fair amount in this kind of weather. In the golf world, seed head suppression, you're pretty late now for your first application of proxy for the spring, which seems very odd to be saying that, but you're pretty late. And if you still have some Embark lying around and you're one of those folks that still use Embark, you still have a little bit of time, particularly into upstate New York and the Hudson Valley. We were talking about soils in the low 50s, mid 50s last week at the 2-inch level. And now you're hard pressed to find the soil in the 50s. And we talked to R.T. Gaetano, who was our guest last week, about this. And of course, in the springtime, that 2-inch soil temperature is going to track the air temperature pretty closely, and even cooler with moisture in there, because, we're wet and we're cool. And we've been cooler than normal region wide, 2 to -2 degrees at normal, maybe a little bit above normal, but not essentially what we would think we'd be warming up. And it looks like cool and wet is coming. The 8 to 14 day probabilities are looking like, at least for the next week, maybe until May, we're going to be pretty wet and cool, which, this is the pretty typical spring stall that we talk about every year. I mean, it was 17 degrees just the other day in Ithaca, and I shuddered. I'm hoping that a lot of fruit trees have not broken dormancy yet, because then they're going to be in all sorts of trouble. Now, when you put all this together and we look at our growth potential model, this is the map, nice and easy to see. Grass isn't growing in New York State, and it's not going to be growing for a few more days anytime soon. And so when you talk about athletic fields, and I thought I'd start out with a picture from Greg Chorvis, a regular contributor and listener to the program, sending a picture from a local school district that I think he worked with a while ago, trying to help him out. And then other people got involved. Maybe you want to believe well-intentioned, but not really smart. About just dumping ditch material. Carl, do I have this right? They cleaned out the community ditches and they dumped it on these baseball fields. And apparently that's not their only problem, because if you take a wrong step, you're going to kill yourself on these stands. So it's obviously clear that the grass isn't growing and fields aren't necessarily in good shape. At this time of year, you get reports that fields are being overused, especially when they're not growing and they look unsafe like this. You put kids on them and all of a sudden you get hurt. And now we start to talk more about face planting concussions, where, concussion care for parents and young people that are on these fields. Again, we oftentimes think of firmness, right? And concussions. I've had some experience having to report about concussions in Division I athletes from my time serving the athletic department here at Cornell. And a number of years ago, we put together a concussion report from various sports, from football and soccer to ice hockey, wrestling, and lacrosse. And you can see we have many, many years where we're above average, whether it's men or women sports. You can get a high number of concussions. Now, obviously, we're not talking about ice in this particular presentation, but we try to make adaptations, right, guys? We try to make adaptations to the game to try to prevent this. And the new kickoff rule in football is certainly a demonstration of that. It's a small percentage of the number of plays in a football game, American football game, but has a higher percentage of concussion and injuries associated with it. And of course, we go and test. And this is where we start to get into the discussion about firmness and testing. And we care a lot about this, but it's almost non-existent at the high school and collegiate level that I'm aware of. In fact, I would think it's safe to say, other than the companies that come in and test the synthetic surfaces, virtually no one in the Ivy League is testing their surfaces for safety and performance, other than the synthetic turf people that put that stuff in. So just to remind everybody, we have a really good sports field management website, which we are in the process now of updating and looking forward to launching that in the next year in an updated fashion. And of course, there's the best management practices for sports fields that the SFMA, or back then the STMA, the New England people really led this charge, and you can find this publication pretty easily on the web anywhere. Okay, Carl, so now I'm ready for you. I was recalling recently that there was, back in maybe 2002 or 2004 or 2006, in the middle of the season, Bill Belichick decides to pull out natural grass and put in synthetic turf. Well, now he's down at UNC with Little Wayne and his new girlfriend, and he wants natural grass. And I'm wondering what this is about from one end to the other where he is. And of course, early I was talking about firmness. Now we're talking about traction, which brings in these multiple forces, right? Not just the downward force, but these rotational forces. And Carl, maybe I hope I set you up enough to start the discussion with Evan.
Yeah, so Evan, you set it up really well. The direction of the force and how we measure that probably matters. We've used, and last year we did this testing about twice a week on our fields, a variety of fields here at Cornell. And we've got the really simple Turf Tech shear strength tester. It's just that coplanar, as Kevin mentioned. You stick it in the ground, you rotate it. It gives you a shearing number, a force that the maximum sort of force before the turf breaks. And there's different things you can put on the bottom. And when we looked at the data last year, we were really looking at it for our soccer teams. We have a Berman, for those watching the yellow line on this graph. That's our game field, Kentucky bluegrass predominantly. Not a whole lot of practices, just games in the fall. McGovern is our practice field. Both men's and women's have their own field. It's a POA Rye field in a satellite location. And when we looked at the traction data last year, that Kentucky bluegrass surface Berman had higher traction numbers in the summer. But as we got into the season, August, September, when we start playing on that field, they really sort of narrowed to match the McGovern field. And if we look at the firmness data, if we look at the ball roll data, they all did the same thing. Berman was sort of different than the practice field. And then they sort of coalesced together towards the end of the year. Now, part of that is probably more rolling. Chris Sitko, our director of grounds and sports turf, took the height down a little bit on the bluegrass. But what he also did was he added ryegrass in June on that bluegrass field at Berman. He got a great catch of that overseeded rye. And as we saw that rye come in, we saw the traction values go down and start to match that POA rye traction of the McGovern field. So now we're starting to think about the growth habit of the grass. Evan, you mentioned, that shearing is really a function of sort of the vegetated growth and organic material down below. So now we're wondering, like, is that why that ryegrass in place of bluegrass? Is that why we're seeing these things coalesce? And then Evan, you guys measure traction in a much more complicated way with the beast, right? this huge machine, you're riding on it. I've got some pictures on here. So now I want to set you up, Evan. Why do you measure traction in this sort of way? It looks like it's coming in at different angles. It's probably rotating. Why do we need that? Whereas the traction device is very simple. Is it too simple? Is it really capturing everything we'd want to know when we're considering traction?
As you alluded, there's excuse me, there's a number of different variables that we need to control in this situation. Athletes have all sorts of different sizes, different cleat engagements, both within sports, within age groups, within even genders. And so this device, the Beast, it's designed very specifically around NFL size athletes. It is configurable, so the weight stack can be changed. But this was developed in response to a desire by the league to really attack lower extremity injuries, which comprise about 60% of the injury burden in the league. So the concussions often gets a lot of the press, but in terms of total time missed, the lower extremity injuries actually play a little bit bigger role. Mm-hmm. So this device, one of the main so that's number one, is that it replicates the loads and the forces associated with the extremely large athletes in the NFL.
Okay,
fast,
so
right?
Carl, you mentioned yesterday, which position, Evan? Is it the linemen who have to plant that heavy weight? Is it the receiver who's running lightly to make a cut? Is it the quarterback who's stepping back and plant? Where do you get the force you want to replicate? Do you go to the most extreme?
Several years ago, there was a biomechanical study done with professional football athletes running around on force plates, highly instrumented artificial turf surface, to get a sense of what are the vertical loads, what are the shearing forces that they actually apply to the surface, how much can they use, how much do they need. And this has been done at other places in the literature in the past, both with American football and with other athletes. So we basically use the 50th percentile NFL athlete to represent this particular test.
Okay.
The other thing that we found, and this actually persists across sports, that generally the most energetic maneuvers apply about 2.5 times the player's body weight to the surface at the peak vertical loading.
Whoa.
Okay. So just to be clear, 300-pound linemen are putting 800 pounds or 700 pounds of force down.
That's right. And that's why this device is so much, it looks so much bigger than an NFL athlete because it is bigger. It weighs a lot more, right? And the other, the other thing to think about positionally is the mode of cleat engagement can vary. You alluded to the linemen sort of digging in at that lower angle. With the receivers, they may be turning abruptly to make a V cut, but they're also often accelerating and decelerating at very high speeds. And oftentimes those high speed decelerations are associated with some of the non-contact injuries like you referred to in the kickoffs. We certainly think of the head-to-head, the sort of violent collisions between the players and their helmets, but also that hard deceleration is associated with a lot of ACL injuries and other things in that sphere.
All right, Carl, what's this?
So this is where I wanted to get to is you guys presented at that Loftsboro International Sport Conference that you turned us on to last year. And this is data from the Beast, right? On a variety of different surfaces. There's synthetic, there's Kentucky bluegrass on its own, there's bluegrass or ryegrass stitched in with the artificial, so these hybrid surfaces. Maybe you could just talk a little bit about some of the findings there, Evan, and what's interesting about different kinds of synthetic, different kinds of natural, and maybe why we're seeing the stuff at Berman with the traction values differing now that we added perennial ryegrass in there.
Totally. Well, I'm always impressed at your guys' ability to find, from one link distill information that you find always the critical thing. So yes, as you mentioned, this was presented at a sports engineering conference last summer, summer of 2024, I guess. And this is an experiment that we did at a couple different locations, including our plot here at Biocore. And the different colors of lines represent the traction response of each surface. So if you haven't seen a graph like this before to the audience, to walk you through it, on the x-axis is the degree of rotation. So it's measured in degrees, starting out from the original cleat position and then rotating through a full turn. And you'll notice that the axis goes all the way up to 100 degrees, which if you think about rotating your knee 100 degrees, that's well past where your ligaments would start to give way, right? So this is we refer to this as an injury test, and we're interested in not only the peak load that builds up, but also the rate that it builds up and how much load is required to move the cleat through a given amount of rotation. So the y-axis here is the torque, which is actually the same unit that you're measuring on that TurfTech shear vane. And you'll notice clearly the numbers are an order of magnitude higher given the higher normal force or the vertical load. So each of the lines represents a different surface tested with this Beast device. And you'll notice there's a big span not only in the peak load, but also the displacement associated with where the cleat releases or where it reaches its maximum force. So for the synthetic turf lines on the left, the gray ones, they're a lot steeper, and they also reach a higher peak load. The purplish lines associated with the bluegrass and the stitched hybrids in the bluegrass at different densities, they tend not to reach quite as high peak load, and they take longer to do so. So that's another thing we're interested in, not only the total force that builds up, but how do you get to that point? And that's one really cool thing that you can measure with this sort of device that isn't captured by a manual or handheld device.
So Carl, before we get to the last slide, Evan, in simple terms, this is you plant your foot and you're more likely to slip a little bit, right, on natural grass, and less likely to slip a little bit on synthetic turf. And when I say slip, I mean the subtlest of sort of slippage that takes that energy away from the joint. Is that a fair
I would
assessment?
agree. I would partially agree. I would shy away from using the term slip. I think oftentimes when we see an athlete slip or we refer to that, it's a more it's a less complete cleat engagement. So oftentimes the studs may not be penetrating all the way into the soil. Maybe it's more like that initial picture you showed of the golf ball, really just touching whether it's the thatch, the mat, however you want to label that sort of intermingled organic layer, or sometimes in a very dense, maybe a ryegrass surface that's wet and slick. Sometimes the cleats don't engage fully. So that's not necessarily what this test is after, but I do agree with the part about in general, the grass is more, we call it more compliant or not as stiff. And so it does begin to release or to deform, at least in a more significant way.
All right. So in my mind, the $64,000 question is, where's the sweet spot? Where am I getting maximum performance and also or optimized performance that also optimizes for my safety? Right? I mean, it looks like where they stitch where you put synthetic fibers in, and I know Ryan Woodley's got this in the outfield now for the Brewers. Um, it looks like where they stitch, it's stiffer, not less compliant, you would say.
Yes, that's correct.
Is it worrisome? Is the stitching now, are they able to, and I'm sure they are, stitch at different densities? And does that then change the stiffness? And is that the way to one of the ways to optimize performance with safety?
I think it is. And so, first of all, just to reiterate what you described, there is a sort of envelope, right? You have the floor of traction where you need to have some be able to run around. It's not like running on a beach, but then
Right.
there's some upper limit where there's a concern that the foot can become fixated. And to answer the second part of your question, I think the purple and the blue lines, hopefully for people that can see, you're not colorblind. I think this is actually colorblind friendly color palette. And Carl, I know you're an R user. This is a colorblind R package by Klaus Wilkie.
Okay.
In any case, the four purple lines, you've got the bottom solid, which is just the pure Kentucky bluegrass, and then stitched at 3 different densities. And so we find that the higher the fiber volume within a given area or root zone volume, as you might expect, the traction becomes stiffer and more significant in terms of the peak load. And so it's interesting because it suggests that you can control the available traction depending on the way the surface is constructed. The blue lines are Bermuda grass with the same stitching rates, and you'll notice they're squashed together a little bit more. And so we would hypothesize that this is probably because the Bermuda grass already has such a robust network of the roots and underground stems that it doesn't. I'll use the word benefit. I don't know if we mean that correct, but at least directionally, it doesn't. It's not enhanced in terms of traction by as much as the bluegrass might be.
And there's maybe why Belichick likes the natural grass going down south or the Bermuda grass going down south.
Oh, there you
Maybe
are
for
coming to
full
his
season.
defense.
If I'm throwing a Hail Mary there on my hypothesis, maybe that's why we like natural grass on the warm seasons that have a
And
lot.
a lot of times it comes down to this debate of grass versus turf, and it's really not as simple as that. And this graph doesn't really depict that super well, but if you squint, you can actually see one gray line that is beneath 2 of the blue lines, which is a hybrid and kind of right in the carpet, the yellow carpet hybrid. So there are some grasses which have higher traction loads, and especially when they're hybridized, than some of the synthetic fields. So oftentimes, coaches especially will get an idea in their head that I want grass, I want turf, and it's not really an absolute. And I'll also just point out that since that happened, I don't remember the year exactly, but it was early 2000s, right?
Yeah.
The technology and the skill of the sod growers has really evolved, and so
100%.
grass in that era probably not so comparable to some of the grass that you can obtain even late in the season now.
Now it is interesting because as we've talked about, or we'll talk about more over the show, is when the World Cup comes, they're going to play on that carpet hybrid grass, right? That's the natural grass planted in a synthetic surface, and that looks like it's pretty strong. Now it's a different animal to a certain extent with soccer. They like that ball to skid, right? It's a round ball sport, but it does look like it's closer to synthetic as far as traction, or less compliant, so to speak, than it is to natural grass. So I'm wondering that if they can also play around with fiber density in that hybrid as well, and I'm sure they're going to use this data to determine what's the best way to go there. Now, John's a pretty smart guy.
Definitely. And again, I want to be clear, this is only 3 products that we tested. One of them we sort of made ourselves, like a homemade kind of off-label carpet hybrid with super high fiber density. And so this doesn't necessarily reflect the suite of products that would be available or might become available anyway.
Okay. All right, Carl, here's your last slide. Let's wrap it up here.
Well, so the great thing is that Evan already nailed this for us. I was going to ask the question, are different athletes, different loads? And Evan, you already answered that. The other part I liked about this slide, Frank, was Declan Rice there, my guy for Arsenal Football Club, with 2 gorgeous free kick goals against Real Madrid the other day. Just top shelf, top level. So we answered, the idea that, maybe different sports and different athletes within a sport, linemen, receivers experience loads differently. But I got a question from Ben Palmer who asked here, Evan, I don't know how much you could talk about this, but you guys collect data for the NFL. Are there instances where the turf, and a lot of that is safety data, right? Are these fields safe? Do we look at injury rates? Probably you can't comment too much on that, but have the turf managers used that data that you collect and implemented certain practices that allow them to get to, higher or lower on the traction scale? Is there anything you can talk to about sort of the turf managers at stadiums using that data from you guys?
Yeah, the turf managers in general are pretty excited about having another tool to look at to track and monitor things over time. We're still sort of in the infancy of determining how do you go from a traction measurement to something you want to do. There's a pretty good amount of research in the literature using other traction devices about how to influence the chute density and potentially the root mass.
Mhm.
The other thing we're excited about is working with the manufacturers and the sod growers, because a lot of times they govern kind of what you're able to deal with once you're the field in the field manager scenario. And in the high end football cases, obviously there's a pretty frequent replacement schedule associated with concerts and also with the high use. So we definitely look forward to providing them, more things that are useful, and that's going to be a focus moving forward.
And I can't let you go without having some conversation. And I know we're over to 30 minutes, Carl, so we weren't as fast as we want to be. But I do want to ask a question about something you just said there, Evan, which is, boy, you really enjoy being able to work with the sod growers, and it feels like turfgrass managers can make adaptations in the things that they manage. Do you find the same thing to be true with synthetic turf manufacturers and people that can manage those fields, or are you more constrained when you get a particular type of synthetic field based on what you've seen in the NFL?
Well, this is one of the beautiful things about natural grass, right? That it can be shaped and molded, ecologically, depending on what the management variables are. And sort of the sports turf manager is the most critical, the spoon that stirs the pot, so to
Yeah.
speak. I do think there's appetite in the synthetic turf world, and you see how it's evolved from, the sort of dark ages of stadium construction, the donut hole stadiums, in
Yeah.
the 1970s, and the turf that people used to play on then,
Ugh.
compared to what it is now. And sometimes how quickly we forget, both on the natural grass side, going back to the early 90s, playing in the Soup Bowl stadiums,
Okay.
and then also the artificial turf. So I think both ends of that dichotomy have progressed pretty significantly, and will continue to do so.
What a very good answer, Evan. You are going to make a really good senior engineer from Biocore. All right,
Or
Carl,
politician,
we're
maybe.
here. It's Evan. It's so great to chat with you. Anytime we can bring up first principle things, right, Carl? With forces and things like that, we're very happy to talk about engineering with a couple of not
Thanks
so
a lot.
bad for a turfgrass guy who turned out to be an engineer with Biocore. Well done, Evan. I
Thank
think your
you.
Brewers need some pitching, though. I'm pretty sure
Yes,
your
they do.
Brewers need some pitching. Your Pirates need some pitching too.
Pirates
Other
are
than that
struggling.
one guy. Ay, ay, ay. Okay, Carl. Good to see you both. Thanks very much, Evan. Everybody, thanks for joining us. We'll see you next week.
See y'all next
Thanks,
week.
guys.
Take care. Thanks
Take
a
care.
lot, Ev. See you, bud.
This has been a production of Cornell University. On the web at cornell.edu.